Today we are continuing to learn how to solve systems of equations. We started off solving systems of equations by graphing. Then we learned how to solve by substitution. We used elimination one day. Then we went into classifying them, whether they are consistent, inconsistent, dependent, or independent. And now we're going to look at solving systems by using elimination again. The first time, we only had to multiply by -1 to make opposites if we even needed to do that. Today we're going to learn how to scale the equations. So you've got two warm-up questions. Solve by graphing and solve using substitution. Pause the video and see if you can do those two now. I do hope you tried. If you're looking at the first one, this one is in slope-intercept form and will be easy to graph. But the second one is not. It is in standard form and we need to change it to slope-intercept form. So 4x plus 2y is equal to -12. Step 1 is to subtract 4x from both sides. (2y) is equal to -4x minus 12. Now, I will divide by 2 all the way across. Y is equal to -2x minus 6. So to graph the first one, where do I begin? I begin at 2. How do I move? 2, which is up 2 and right 1. So I'll start at 2, I'll go up 1, 2, and right 1. 1, 2, right 1. Now I am ready to draw my line. Okay, for the other one, where do we begin at? At -6. Okay, my move is -2. Ordinarily, I would go down 2 and right 1, but that takes me off the graph, so I'm going to do the opposite, which is up 2 and left 1. So I'll go up 1, 2, left 1. 1, 2, left 1. Now I am ready to draw my graph. You can see the point of intersection. The solution is -2, -2. So that's how you solve by graphing. You need to, if it's not in slope-intercept form, you have to convert it. And then if you can't move the way we normally do, we do it totally opposite. For the next one, we're going to solve using substitution. Okay, I've got to solve for x or for y. If I look at the second equation, I can see by adding x to both sides, I have solved for y. So I am going to add x to both sides. y is equal to x plus 3. Now I can substitute in and solve. I have to use that first equation, negative 3x plus 3 times x plus 3 is equal to 4. We have to distribute to begin with and then simplify both sides, the left side. Negative 3x plus 3 times x is 3x. 3 times 3 is 9. 3x plus 9 equals 4. Negative 3x plus 3x is 0 x's. I end up with 9 is equal to 4. Does that ever happen? Is 9 ever equal to 4? No. 9 is not equal to 4. There is no solution. What do we know about the two lines? They will be parallel. Remember, your solution is the point or points in common. Okay, this takes us into learning how to scale one or both equations so that we can eliminate. Scaling means that we multiply every term by a number. So if I want to scale by 4, this becomes 4 times 3x minus 4 times 5y equals 4 times 2. You multiply every single term by 4. 4 times 3x is 12x. Negative 4 times 5 is negative 20y. Negative 4 times 5y is negative 20y. 4 times 2 is 8. And that is what the scaled version looks like. These two, 3x minus 5y equals 2, and 12x minus 20y equal 8, are the same line. So what about scaling by negative 3? Pause the video and see if you can do that on your own. I hope you tried. So this becomes negative 3 times negative 2x plus negative 3 times 3y equals negative 3 times negative 8. Negative 3 times negative 2x, negative times negative is a positive, it's 6x. Plus negative 3 times 3y, negative times the positive is a negative, so it's negative 3 times 3y is 9y, is equal to negative 3 times negative 8 is 24. These two equations result in the same line. Okay, so we're going to look at solving now. If I'm looking at, I've got negative 6x, negative 6x, 6y, 3y, 6 and negative 12. If I want to do this, then I need to scale, I need one of these to be the opposite. So that means I can multiply everything by negative 1. When I multiply everything by negative 1, I simply change the signs to their opposites. I'm going to do the bottom equation because I want to get rid of the negative 12. So this becomes positive 6x negative 3x, and positive 12. I've now created opposites. Negative 6x plus 6x is 0. I've eliminated my x values, and I can solve for y. 6y minus 3y is 3y, is equal to 6 plus 12 is 18. Divide by 3, and y is equal to 6. But I still have to find x. I still have to find x. So, I'm going to use the first one. Negative 6x plus 6 times 6 is equal to 6. Negative 6x plus 36 is equal to 6. Subtract 36 from both sides. Negative 6x, this is gone, is equal to negative 36 plus 6 is negative 30. Divide by negative 6, and x is equal to 5. So my solution is the point 5, 6. So if you have any questions, back the video up and watch it again. We're learning how to multiply to scale an equation to create opposites. Okay, so I'm going to look. I have to create opposites, and I'm always going to be thinking about the best way to do that. I've got negative 4x, I've got positive x. I've got 9y, I've got negative 3y. So I can either, there's two ways to do it. I can multiply the bottom row by positive 4, and then I'll have negative 4x and positive 4x. Or I can multiply the bottom row by 3, and I'll have positive 9y and negative 3y. So, which way do you think would be better? If we use 4, we're going to have bigger numbers than if we use 3. But if that's what you want to do, that is perfectly acceptable. I think that for the example, though, we're going to multiply everything here by 3. We know that the negative 4x plus 9y equals 9 will not change. 3 times x is 3x. 3 times negative 3y is negative 9y equals 3 times negative 6 is negative 18. We have created our opposites. We've got negative 9y and positive 9y. That eliminates. Negative 4x plus 3x is negative x is equal to 9 plus negative 18 is negative 9. If the opposite of x is negative 9, then x must be equal to positive 9. We need to find y. The easiest way is to use the second equation. The second equation, before we scaled it, is the easiest one to use. So I've got x minus 3y is equal to negative 6, but x is 9. 9 minus 3y is equal to negative 6. I'm ready to solve. I'll subtract 9 from both sides. Negative 3y is equal to negative 15. Negative 6 plus 9, and negative 9 is negative 15. Divide by negative 3. And y is equal to positive 5. Take a minute and look and make sure you were following along correctly. So my solution is the point 9, 5. Okay, now it's your turn. You've got two systems of equations. Pause the video and do the first one. Check your answer and make sure you're doing it correctly. If you are, do the second one. If you're not, ask me for help. Well, I hope you were able to do it on your own. If I'm looking at this, I've got negative 7, negative 2x, negative 7x. I would have to change both of those. Here I've got y and I've got 3y. If I multiply this by negative 3, I will create my opposites. Okay, negative 3 times negative 7x is 21x. Negative 3 times positive y is negative 3y. Negative 3 times negative 19. If it was 3 times 20, it would be 60, but this has to be 3 less, so it will be 57. Negative 3, negative times negative is a positive, so it will be positive 57. This one doesn't change, so it's negative 2x plus 3y equals negative 19. I have created opposites for my y. They're gone. 21 minus 2 is 19. 19x is equal to 57 minus 19. Which gives me positive 38. I'm going to divide both sides by 19. 19 is half of 38, so x is equal to 2. Now you've still got to decide whether to use the first or the second equation. Does not matter. So if I'm going to use the second equation, negative 2x plus 3y is equal to negative 19. Negative 2 times 2 plus 3y is equal to negative 19. Negative 4 plus 3y is equal to negative 19. So I'm going to add 4 to both sides. Three y is equal to, they're opposites, so I find their difference. 19 minus 4 is 15, but it will be a negative 15 because the 19 is negative. Divide both sides by 3, and y is equal to negative 5. Okay, take a minute and look. Do you have any questions on how this is done? Okay, find your solution. Your solution is the point 2, negative 5. Okay, for the last one, we've got a 3 and a 5, a -2 and a -5. Those are your coefficients. This tells me I am going to have to scale both equations to find my opposites. So, do I want to multiply by 2 and 5 or by 3 and 5? That's a question you ask. It doesn't matter which one you do, it's going to be about the same in level of difficulty. So what do you think? I'm thinking that we will multiply, and since these are both positives, we will have to do a negative. So I'm going to multiply the first one by +5 and the second one by -3, because I'll end up with 15x and -15x. So 3x times 5 is 15x, minus 5 times 2y is 10y, is equal to 5 times 2 is 10. That's your first equation. 5 times -3 is -15x. -3 times -5y is +15y. -3 times 10 is -30. I am ready to solve. 15y minus 15y is 0. -10y plus 15y is 5y, is equal to 10 plus -30 is -20. Opposite signs, so we subtract, keep the symbol of the larger number. Last step to solve is to divide both sides by 5. And we know that y is equal to -4. Which one do we want to use? Does not matter. We'll use either the first equation or the second. The second one might be more interesting, but the first one might be easier. So what are we going to do? Let's use the first one. We've got 3x minus 2y is equal to 2, but we know y is -4. 3x minus 2 times -4 is equal to 2. 3x plus 8, -2 times -4 is 8, is equal to 2. Now I'm ready to solve. Subtract 8 from both sides. Three x is equal to 2 plus -8 is -6. Divide by 3. And x is equal to -2. So my solution is the point -2, -4. And that is how you solve when you have to scale one or both of your equations for elimination. So how do you know when you're successful? When you can solve any systems of equations. Solving with elimination specifically scaling equations. Scaling means that we multiply every term by the same number. When we get done, we have the same graph, but the equations look different.